Another kind of question is to find the equation of the tangent line to the graph of a function at a particular point. In this case, we're looking at the graph of the function square root of 2x squared plus x plus 4 at x equals 3. According to what we have seen about tangent lines, this tangent line is the line that has slope derivative of this function at x equals 3 and passes through the point on the graph of the function corresponding to x equals 3. In other words, it has first coordinate 3, second coordinate f of 3. If we plug x equals 3 in this function, under the radical we get 3 squared is 9 times 2, 18, plus 3 plus 4, so that's 18 plus 7, 25. Root of 25 is 5, so the second coordinate of the point of tangency is 5. On the other end, to obtain the derivative, we're going to use a chain rule because we have the function 2x squared plus x plus 4 that is plugged inside the square root function. So here our function f in the chain rule is 2x squared plus x plus 4. The function g is just a square root function. According to the chain rule, to differentiate this, we obtain the derivative of the outside function, in our case the square root function. Derivative of the square root is 1 over 2 square root. We evaluate at the function inside, so we get 1 over 2 square root of 2x squared plus x plus 4. But then we have to multiply by the derivative of the function inside, in other words, derivative of 2x squared plus x plus 4. This derivative is 4x plus 1. So this is how we obtain the derivative of our function. And now the slope of the tangent line to the graph of that function is the value of this derivative at x equals 3. So we plug x equals 3 in this. At the top we have 4 times 3, 12, plus 1, 13. At the bottom, 2 times the value of the square root at 3, but we know, we already observed that this is 5, so we get 13 over 10. So now, the tangent line is the line of slope 13 tenths that passes through the point of coordinate 3, 5. And therefore, an equation for this line is y minus 5 equal 13 tenths of x minus 3. Let's look at a more concrete type of problem. Here we have environmental study of a certain suburban community that suggests that the average daily level of carbon monoxide in the air is given as a function of the population P in thousands. And this function is the square root of 0.5 p squared plus 17. On the other hand, there is also an estimate for the growth of the population. Specifically, it is estimated that t years from now, the population of that community will be given by p as a function of t is 3.1 plus 0.1 t squared. Remember that p is in thousands of people. And we want to know at what rate will the carbon monoxide level be changing with respect to time 3 years from now. In other words, we want the rate of change of the level of carbon monoxide with respect to time t, that is, we're looking for dc over dt, the derivative of c as a function of t, and we want the value of this function when t is 3. C here is the level of carbon monoxide is given to us as a function of, not as a function of time, but as a function of the population. However, since the population itself is a function of time, we can think of C as a function of time. But according to the chain rule, when we differentiate C with respect to time, we can first differentiate with respect to population, but then we have to multiply by the derivative of the population function with respect to time. So in our case, if I differentiate C with respect to the population P, as a function of P, C is itself a composite function. We have the function 0.5 p squared plus 17 that is plugged inside the square root function. Using the chain rule, we obtain derivative of the outside function, so derivative of the square root, that's 1 over 2 square root, evaluated at the inside function, 0.5 p squared plus 17. And this is multiplied by the derivative of the function inside, which is 0.5 multiplied by 2p. All this, right, this part is just the derivative of c with respect to p. All this is multiplied by the derivative of the population with respect to time. Simplifying a little bit, at the top, the 0.5 multiplied by 2p is simply 1p, and the derivative of p with respect to time can be replaced by 0.1 multiplied by 2t, because as a function of time, population is simply 3.1 plus 0.1t squared. Replacing p by its value in terms of time, we obtain the derivative of c with respect to time as a function of time. And now we only need to plug t equals 3 in this function. After simplification, we obtain 0.24. And this is in parts per million. Now I would suggest that you turn to your homework set on the chain rule, and after you are done with that, you can do the sample quiz on the chain rule and then take the quiz.